Rational inequalities. This is going to be the last video of this unit. What we're going to be doing is solving inequalities that look like this. Okay, my main approach at how to do this is going to be not using graphs. You're going to notice that I do have a grid over here. So when I'm done doing this algebraically, we're going to go ahead and look at a picture and verify that the work that we have done actually is correct. The way that we're going to approach this is a three-step process. Step one, we're going to set one side of the inequality equal to 0. In other words, we're going to move one of the sides over to the other one. Step two, we're going to identify critical numbers. Those will be x values that make the numerator or the denominator 0. If the numerator becomes 0, we're actually referring to roots. That's what we'd be looking at. If we're looking at where the denominator is 0, those would be wholes or asymptotes. Okay, so it's important that we do understand the difference between what we're looking at, because some values will be undefined. That would be when the denominator is 0. But when the numerator is 0, those are going to be x-intercepts. So those values will be defined. However, if you do have a factor that exists in the numerator and the denominator, then that would be a whole and not actually a root. Okay, so we're going to be careful on that part there. All right, step one, what we're going to do is move one of the sides of the inequality over to the other end. Most likely, this will be your better choice here because it's simply just an x. Now, to move that to the other side, what you're going to do is subtract that. Okay, so we're going to keep this part just as it is. The x is going to get subtracted over. After the x does move over, we are going to want to group it with this rational expression. So, as I move it over, what I'm going to do is consider how would I give it a common denominator? Because right now, this is just x over 1. Okay, so the common denominator is going to be x minus 2. All right, so as I move it over, we're going to use subtraction. I'm going to have a rational expression. Okay, I'm going to have a numerator and a denominator. It's going to be an x multiplied by x minus 2. Then the bottom is also going to get multiplied by x minus 2. So those are things I can take care of at the same time. And all of this will be greater than 0. And what that means graphically, even though we're going to approach the problem algebraically, what it means graphically would be to be above the x-axis. Not equal to the x-axis, but strictly above it, which in the algebraic approach, we can just think of as positive numbers. All right, so we're going to go ahead and group these together. We do have an x squared here. You're also going to get an x squared here, but that one's going to be a negative x squared, so that's actually going to cancel out. The negative x is also going to distribute to the negative 2, which is going to give you a positive 2x, which is also going to cancel out with this negative 2x. So a bunch of things are canceling out, but the one part you are going to be keeping is that 1. You're going to have 1 over the common denominator, x minus 2. And that needs to be greater than 0. All right, so step two, we're going to identify any critical numbers, numbers that would make the numerator or the denominator equal to 0. In this case, well, the top is only a 1, so there's nothing there. But the denominator, if you were to plug in a 2 here, it would become undefined. And that's going to represent an asymptote when we look at this graphically. Okay, so I'm going to draw a little number line here, mark off 2. That is our only critical number. And I'm going to make a note here that 2 is undefined. Okay, it's important that I understand that's not an x-intercept, that is actually an asymptote that I'm looking at. Okay, and then to answer the rest of the question, what I'm going to do is just choose values that would be below 2 and greater than 2, and plug those into this expression to see if I get positive numbers. Okay, so if I were to plug in a 0, which is to the left of the 2, if I plugged in a 0, I would get 1 over negative 2, which is negative. We're going to be negative on that side. If I choose a value greater than 2, like 3, plug in a 3, I'm going to get a positive 1 on the bottom. You can get 1 divided by 1. Point is that it's positive. So over here. So our answer to this whole thing is just going to be what values will be greater than 0 when you plug them into this thing. And those are going to be any values that are greater than 2. So our answer is going to be an open interval from 2 to infinity. All right, so let's go ahead and take a look at this graphically to see how that supports our answer. Okay, and what I'm going to have to graph is our simplified version. Getting this into the calculator and interpreting what that means is going to be difficult. But once we get to this point, we're really going to be comparing it to the x-axis, which visually is something very easy to do. All right, so there's the graph. We do have a vertical asymptote at 2, which was suggested before. In addition, we do have a horizontal asymptote at the x-axis. We could go ahead and add that in if we wanted. The graph is going to exist here and here. And with respect to the x-axis, what we wanted to do is find all the values that would make this over the x-axis. And that exists over here, an open interval from 2, so it does not include 2 since that's an asymptote, and it extends forever to the right, which will be infinity. Example 2, we're going to solve this. Not much different than what we just looked at, except you do have a greater than or equal to, which means that we'll be including any roots that we have. So it's going to be very important that we identify what is undefined and what is actually defined as a root. First step, let's move this over here so that we can get a 0 on that end, and then we can actually compare to the x-axis. Okay, so we're going to have 6 over x minus 2. This is going to move over as addition. You're going to get plus 4. But we're going to build a fraction out of this using that as a common denominator. Okay, so the top will also get multiplied by x minus 2. This will be greater than or equal to 0. So roots will be included as part of our solution set here. We're going to go ahead and group both of these together as a single rational expression. For this, I'm going to do it in a couple of steps. Okay, so I got the 6, then I'm going to have a plus 4x plus 4. Okay, so the positive 4 times negative 2, that's going to give us a negative 8, everything over x minus 2, greater than or equal to 0. All right, so I'm going to group terms now. I can group these two together, which is going to give me a negative 2. So I'm going to write this as 4x minus 2 over x minus 2 is greater than or equal to 0. Okay, now from here I'm going to identify any of my critical numbers. Okay, and I'm going to draw that little number line just for reference. We definitely have one at 2. Okay, now does that make the top a 0 as well though? Okay, so if I were to plug in a 2 here, I'd get 8 minus 2, which is 6. Okay, so this is going to be an asymptote. It's going to be undefined, but it's an asymptote. The other critical value that we're going to get is going to come from the numerator. It's going to be positive 2 divided by 4. It's going to be 2 over 4, which is the same thing as 1/2. And in other words, 1/2 is an x-intercept for this. All right, so I'm going to have 3 regions that I need to check. I'm going to start with 0, which will be located over here. It's less than 1/2. And if I plug 0 in, these are just going to become 0. So you're left with negative 2 over negative 2, which is a 1, or a positive 1. So this is positive. All right, between these two, we could choose the number 1. Okay, so if we plug in 1, we're going to get 4 minus 2, which is positive. We're going to get 1 minus 2, which is negative. So overall, it becomes negative. The last section, anything greater than 2, suppose we put in 3, that would give you 12 minus 2, which is positive. That would give you 3 minus 2, which is also positive. So we're positive here as well. So if we want the values of x that'll make this greater than or equal to 0, that would be these positive sections and this root that we have. Okay, so we're going to get negative infinity up to 1/2. That's going to be a bracket because it includes it. We also get open to infinity. All right, so let's take a look at this in the graph just to see how it compares. Things that we do see. We do have that vertical asymptote at 2. Let's go ahead and add that in. We also have a horizontal asymptote, right? We have a horizontal asymptote, and that is going to be because the degrees here are equal. So we're going to reduce it down to 4 over 1, which is going to put that horizontal asymptote at 4. The 1/2 is going to be an intercept right there. You could probably go ahead and figure out the y-intercept for this as well. I didn't do that in the last example. Probably could have, though. The y-intercept is going to be when x is 0, so that will leave you with -2 over -2, which is 1. So you could plot a point there. And if we do some comparison, there's that 1/2, there's that 1. Okay, so the graph is over here. See if we can get it to go through that point. That looks better. The rest of the graph is up here. Not going to worry about any particular points, but it's up there. And the point is, we want all the parts of the graph that are going to be greater than or equal to 0. So we got -infinity to 1/2. We have from here up until that point, and including that point because it's got the equal to, but then we stop. We don't accept this part over here because that'll be underneath the x-axis. But then it picks up after the asymptote at 2 and goes on forever. Okay, that part is above the x-axis. All right, we got one more to look at, one more that does not have an x minus 2 in the denominator. In fact, you've got two different denominators here, so it's going to be a little bit more extensive in getting that common denominator. Not impossible, but there's a little bit of extra work. Here's another thing I want you to know. The graph is going to cross the horizontal asymptote. It's going to cross the horizontal asymptote on the left. That is something that we're going to see in the graph. But remember, the approach at actually doing this can all be done algebraically. We can get our answers algebraically without even needing to know that that's happening. Okay, but it is going to show up in the picture, and I want to highlight that when we get to that actual point. Okay, let's go ahead and think about moving this over to that side. So that's going to happen through subtraction. But when that does, when we move it over, we're still going to need to get a common denominator. The common denominator is going to be a combination of the x minus 4 and the x plus 4. Okay, so this first fraction, that's going to look like this. You're going to have 5 over the x minus 4. But to get that common denominator, we're going to multiply the top and bottom by x plus 4. Okay, and then we're using subtraction to get that to move over. You're going to have a 1 on top, which really isn't going to be important to write. What we are going to have is going to be an x plus 4. The top and bottom are going to get multiplied by x minus 4. Okay, and that's the reason why I don't really need the 1. Otherwise, you would need it. All right, so now grouping things together, we're going to get 5x. We'll need to simplify this first. You're going to get 5x plus 20. We're going to be subtracting, so that'll distribute in. Subtract x, but plus 4. Okay, so I'm going to go ahead and finish that part. That's going to give us 4x. Actually, I want to do it this way. Save a little space. This is going to be equal to 4x plus 24. Okay, what I had noticed when I was starting to write that is these both have a factor of 4. So it's going to be easier if I just remove that factor of 4. Okay? So I'm going to make it look like this. It's going to be 4 times x plus 6. We're going to place that over these. And everything needs to be less than 0. Okay, that goes all the way back to the top here. It needs to be less than 0. All right, so for test values, for our test values here, anything that makes the denominator 0, that would be 4 and -4, okay? And those are not factors in the numerator, so those are actually asymptotes. Okay, so we're going to have -4, we're going to have a +4. This time I'm going to go ahead and put an a there because those are going to be asymptotes. The numerator, -6. That is going to give us a root over there, okay? So you actually have a root at that spot. These are going to be asymptotes. And now we've got 1, 2, 3, 4 sections that we have to run tests with. Okay, now the common one is always to go with 0, which is actually going to be located over here. If we were to put a 0 in this, the top would end up being positive because you'd have 6 times 4, so just think positive. This would be negative. This would be positive. So having only one negative, this section is going to be negative. All right, so let's choose some other numbers. Way out here, past -6. In fact, I'm going to exaggerate and think about maybe something like -10, a larger number. Okay, instead of something weird like 7, we'll just use -10. Okay, now if I were to put a -10 in here, that will become negative, which makes the whole top negative. So I've got one negative. If I put -10 here, I also get a negative number. Okay, I'm getting -14. So I've got negative and negative, got 2 of them. If I put -10 here, that is also going to be negative. So I get a total of 3 negatives, which means that it's going to overall be negative. Okay, every 2 negatives becomes positive, but we got 3 of them, got an odd amount. Here, we're going to go at -5. Okay, if -5 goes there, we get a positive 1, so top is positive. -5 here gives you -9, so we got 1 negative. If you put -5 here, you're going to get -1, so we got 2 negatives. They're going to cancel, everything becomes positive. Out over here, let's just go with 5. If we put 5 in, positive. Put 5 in, positive. Put 5 here, also positive. Everything's positive. Okay, so kind of just checkerboards its way through that. And as far as our solutions then, we need all of the values that are going to be less than 0. Okay, so it will also not include this one. So our negative regions are going to be negative infinity up to 6. Not 6, -6. And that's going to have to be open because we don't have the equal to. And you get the open interval -4 to 4. That'll be our solution set. Okay, and remember, I'm doing all of this algebraically. I'm not actually using the graphs to do this. All right, so with that typed in, we're going to go ahead and graph it. We're going to get a couple of asymptotes. There we are. We got an asymptote at -4. We've got an asymptote at +4. And even though the x-axis, you can see here is a horizontal asymptote, we do cross at -6. Okay, so it's going to cross through it. What the graph is going to do is dip just slightly, and then it's going to come back to the x-axis, which is really hard to draw, by the way, but that's what's actually happening here. All right, I can also go ahead and plot the point here at -6. Okay, and the graph, it's going to be coming from the top. It's going to go through that just slightly, and then it heads back towards that horizontal asymptote. It does eventually settle off at the 0. Over here, the y-intercept, we could probably estimate. I don't think it's going to be that great of a number. If we were to put a 0 in, we would get 24 divided by -16, which is going to be 24 divided by -16 is going to give us, oh, that looks pretty good, -1.5. All right, so right here, we're going to have that spot. Now, the graph, it's not symmetric. Okay, it kind of goes up, back through that point. Yeah, if I could hit that point. Okay, and then this section we'll just generally sketch it. But look, our answers. When is this less than 0? Coming from -infinity up to 6, but not including it, we get that part. We're going to skip over that because it's positive. Pick up after the asymptote. You've got that open interval from -4 to 4 that we're going to keep. That is all negative. This is positive, so we don't accept that part either.
Wait, what?